Good afternoon. My name is Eric James. This is FTE 217 Modern Sporting Rifle Week 3 assignment. The date today is October 26, 2024. For this assignment, we were asked to identify and choose 3 components on our AR rifles, giving the critical dimension for each of the 3 components, also giving the potential malfunctions that can occur from damage or improper modification, what damage is likely, if any, on those components and why is that a problem, and then what training we as gunsmiths should undergo to avoid causing damage to those components. Finally, we are also asked to identify the components that interact with the components we selected and determine their critical dimensions. So without further ado, I'm going to break down the rifle, but before I can do that, I have to render it safe. We'll drop the magazine, feed source filled with snap caps, bolt to the rear, visually inspect that there's no ammunition in the chamber, there's no ammunition in the mag well. This rifle is safe. So what I'll do from here is I will tear the rifle back down off camera and come back once that's complete. All right, we're back. Rifle is completely disassembled, as you saw in the picture. The first component that I chose to talk about critical dimensions with are the feed ramps. The feed ramp critical dimension is the angle at which the round interacts with the barrel extension and the receiver going into battery, running the round into the chamber. A potential malfunction that may or may not occur due to damages would be a failure to feed, and what that essentially would be is the round being stripped off the top of the magazine and contacting the lower receiver and getting stuck on the barrel extension. The AR-15 bench manual gave us a few examples of good barrel extension to receiver matches. One specific one, the AR barrel extension to M4 receiver, was one that should be shied away from, just because the angle on the barrel extension does not match the receiver extension or the receiver angle. In order to fix that, a gunsmith would have to take a rotary tool and a carbide burr or some kind of a burr tool and smooth out the difference between the two. So the additional components that interact with feed ramps would be the bolt, the locking surface of the bolt, these outside edges locking into the barrel extension, keeping the bolt in battery until the rifle is fired and the cycle of operations goes. The critical dimension of that part on both ends are the locking lugs. So each one of these lugs is its own critical dimension. It goes into the receiver, turns on the pivot pin, and locks into the receiver so that it doesn't move. Also, what goes along with that is the firing pin. Firing pin rides down the center of the bolt and strikes the primer and ignites the chain reaction that is firing. Moving on to the next component that I chose, would be the trigger, or the hammer, I'm sorry, and the trigger itself as a system, not just an individual component, but as a system. So the first critical dimension on the hammer is this sear notch right behind the pivot pin hole. No, it's this ledge. That ledge, when the hammer is cocked, grabs the trigger, this edge of the front edge of the trigger, and that's what's held until the trigger is pulled. The hammer will rotate forward. On the cocking step of the cycle of operations, this disconnector sear surface interacts with the disconnector in that fashion right there. And then finally, the hammer, the face of the hammer itself. Some malfunctions that can occur due to damage or improper modification is a trigger that is too light, an angle that is cut into that surface that is too shallow for trigger to engage, causing, in the case of a machine gun, it'd be a runaway gun, but causing the hammer to fall prematurely. Just a bump knocked that hammer loose, causing the next round to go off. Same thing with this. Malfunction would be the trigger not resetting or not feeling the reset, just because the disconnector disconnects the hammer from the trigger until you let the trigger back to normal. And it lets it go, and the sear face or the sear surface on the trigger and the hammer interact with each other. The components that these interact with is the safety. That the trigger specifically interacts with the safety. You can't see it, but if you put it on fire, there's a flat spot for the hammer to come up into and stop it from over rotating. It also interacts with, like I said earlier, the firing pin and the bolt and bolt carrier group. The hammer hits the back of the firing pin, sending it through the bolt face into the primer, igniting the chain reaction. Finally, the extractor, and I did not pull this all the way apart. The critical dimension of the extractor is this lug in here. That lug grabs the rim of the case and pulls it from the chamber. A malfunction with this would be a failure to extract. If that extractor lug has been broken off, filed down, or the spring tension behind here, this is the extractor, back here is the extractor spring. If the spring is broke or damaged, that extractor will just kind of flop in there, causing issues. Components that the extractor interacts with is the bolt itself. Like I said earlier, the critical dimensions of the bolt are the locking lugs, and then the ejector button right here. And the critical dimensions of the ejector is the spring tension, the tension that's required to send the bolt out, or the round out. The locking face locks the barrel extension of the bolt together. That's it. So that concludes week 2 or week 3 assignment. Thanks for watching. My name's Eric James.